A motor car starting from rest, again we are going to summarize our question in a diagrammatic way. A motor car that is starting from rest and moving with uniform acceleration goes 9.5 meters in the 10th second after starting. So if we are to illustrate that diagrammatically, we have a motor car starting from rest, meaning that its initial velocity is 0 and it is going after 1 second, after 2 seconds, and then it continues into the 9th second, then into the 10th second. So it's telling us that it goes 9.5 meters in the 10th second. So it means that between the 9th, between there and there, this is the 10th, because from this is the first, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the 9th. Then the 10th second, it goes 9.5 meters in the 10th second after starting. Find the acceleration of the car. So they want you to find the acceleration of the car and the distance covered during 5 seconds from start. So after finding the acceleration, they want you to find the distance covered after 5 seconds, S subscript 5. Again, here the technique we are going to use is the fact that we know that it is moving 9.5 meters in the 10th second. So it means we are going to get the expression for the distance covered after 10 seconds minus the distance covered after 9 seconds, so that we are able to equate it to 9.5, and within there we are able to get our value of acceleration A. So it means in this case we are going to get the distance covered after 10 seconds, S10, is going to be equal to UT plus a half AT squared. But we know that U, initial velocity, is 0, so 0 times T, this whole thing is 0, plus a half, so it's going to be a half times acceleration, which you do not know which you're looking for, times time squared. T is 10, so it is 10 squared. So you'll find that your value of the S10, or the distance covered after 10 seconds, so call it the displacement after 10 seconds, is going to be 100 A over 2. So that is S10. So now let's go ahead and find the distance covered after 9 seconds. The expression for S9 is going to be equal to, still again, UT plus a half AT squared. That's going to be initial velocity 0, here is 0, so it's 0 times T, this whole term would die, plus a half, so we have a half, times the acceleration. The acceleration in this case, it's going to be not known yet, times the time squared, which is 9 squared, which is 81. So we shall end up with 81A, divide all that by 2. That is S9. So we know that to get the distance covered after 10 seconds minus the distance covered after 9 seconds, we will be able to get the 9.5 meters. Or to make it more clearer for some of us who may not have gotten it yet, we have gotten the expression for how much have we moved after 10 seconds. We've moved from here, that's S10. Then the distance covered after 9 seconds is that, from here up to there. This is S9, like that. So to be able to get the 9.5 means we are going to get the distance covered after 10 seconds minus the distance covered after 9 seconds to be able to get the 9.5. So it means, in simple terms, this simply means that S10 minus S9 is equal to 9.5, and from that expression we are able to get our value of acceleration. So S10 is 100A over 2 minus S9, which is 81A over 2, giving us 9.5. Of course, when we work it out, we shall end up with our acceleration being 1. So that's the acceleration we get. So the other part of the question is asking us to find the distance covered during 5 seconds from start. The distance covered during the 5 seconds from start. It is different from saying the distance covered during the 5th second. Here they want the distance covered during 5 seconds from start. So it means to get the distance covered 5 seconds from start, we shall say the distance covered during 5 seconds from start is going to be equal to ut still plus a half at squared. This is going to be initial velocity, which is still 0 times t, so this whole term is 0, plus a half, which is a half, times the acceleration. We got the acceleration as 1 meters per second, times time, which is 5 seconds, which is 5 squared. So we shall end up with 25.
This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.